Hello everyone, welcome to the channel. We have I to the power of x is equal to 1 plus I, an interesting exponential equation. Now my friends, the integer powers of I are I to the first power is I, of course. I squared is negative 1 by definition. I cubed is I squared times I, which is negative I. And I to the fourth power is equal to plus 1 from I squared times I squared. And after the fourth power, that repeats itself. But we need a power that I to the that power is equal to 1 plus I. To solve this equation, we will need the polar coordinates and Euler's notation. Let me talk shortly about that. We have the complex plane, real and imaginary axes here. And we have a complex number, say a plus bi, z is equal to a plus bi. Then the real part is a and the complex part, imaginary part, is b. So we have this line just adjoining the origin and our complex number, and we have this angle theta here. We will have r, the length of our complex number, the modulus. This is equal to square root of a squared plus b squared from the Pythagorean theorem, and theta is, let me show you, tangent theta is equal to b over a. Then theta is arctangent of the inverse tangent of b over a. Also we can say a is equal to r times cosine theta and b is equal to r times sine theta. Then our z is equal to a plus bi becomes, z is equal to a plus bi becomes r times cosine theta, plus I sine theta. This is the polar coordinates, or this is equal to r times e to the power of I theta. This is the Euler's notation. Now my friends, with this knowledge, now we can say I is equal to, let me show you where I stands. I stands on the imaginary axis with an angle 90 degrees. Theta is pi over 2 and the length here is 1. So I is equal to 1 times e to the power of I theta, which is pi over 2. So I is equal to e to the power of I times pi over 2. What about 1 plus I? Let us see 1 plus I. That is, the real part is 1 and the imaginary part is 1 again. So z is equal to 1 plus I. Stand here with an angle of 45 degrees or pi over 4. Here we have theta, let's say alpha. This is equal to pi over 4. And the length here, r, is equal to the square root of 1 squared plus 1 squared. This is equal to root 2. Then our 1 plus I becomes root 2 times e to the power of I times pi over 4. Let's just plug these into our equation. We have the original equation is I to the power of x is equal to 1 plus I. We have found I is e to the power of I pi over 2. Raise it to the power of x is equal to root 2 times e to the power of I pi over 4. Now we will ln both sides. That ln of e to the power of I times pi over 2 times x. This is equal to ln root 2 times e to the power of I pi over 4. Then from the properties of logs, we will have the power I times pi over 2 times x. I times pi over 2 times x is equal to, we can write this as a sum of ln's, ln root 2 plus ln root 2 plus this I times pi over 4. Again, cancelling ln e, we will have the power, the exponent I times pi over 4. So x is equal to this ln 2 plus ln root 2 plus I times pi over 4 all divided by I times pi over 2. This is the result. Let me just multiply by 2 and I, 2i, here and here, multiply by 2i, then we will have x is equal to 2i times ln root 2 plus 2i squared times pi over 4 all divided by these 2's and I will cancel. No, 2's cancel. We have I squared times pi, which is -1. I squared is -1. So we will have, here we will have -1. 2 and 4 will cancel. We will have 2. This is again -1. So we can write this as, we have negative pi over 2 here. With the negative again, we have pi over 2 minus this 2i ln root 2 divided by pi is our final result, I guess. Thank you for watching and see you in the next videos.